Good morning. Today we will discuss about trigonometry. In few minutes we'll start. 4 to 5 minutes we'll start. Okay, so I'm not going to the sound quality. Still, we will start the sound two problems. Okay, so in the last class, I have discussed about introduction to trigonometry. We have discussed different properties like the relations between ratios. So we have discussed that in a right angle triangle, the ratio of the sides are like this, like sine theta is PIH, that is PB by AC. Okay, so cos theta equal to b by h, and here it is bc by ac. And equal to tan theta equal to p by b, tan theta is equal to p by b. So this is your p, this is your b, eb by bc basically. Cot theta equal to b by p. This is bc by ab. So this is BC by AB. Now sec theta equal to h by p, h by b, exactly reverse of your cos theta. So h is here, hypotenuse. H by b, that means AC upon BC. AC upon BC here. And then you can see cosec theta is h by p. This is your AC, is your hypotenuse. So it will be AC upon AB. AC upon AB. So by looking at the ratios, you can compare here. Cos theta and sec theta are just inverse to each other. Sin theta and cosec theta are inverse. Then cot theta and tan theta are just inverse to each other. So I can write that sin and cosec are just inverse. So cosec theta is equal to 1 upon sin theta, I can write, because you can see cosec theta is h by p, sin theta is p by h, just inverse. So cosec theta is 1 upon sin theta, I can write. This is the relationship. Let's say relation 1. Then relation 2, similarly you can write sec and cos are inverse to each other. So you can write cos theta equal to 1 upon sec theta, And cot theta and tan theta, they are also inverse to each other. So you can write cos cot theta equal to 1 upon tan theta. Now let us find out some identities, right? So few identities I'll write, like one important identity, that is sin square theta plus cos square theta equal to 1. This is very important and you will use this one in many places. Sin square theta plus cos square theta equal to 1. Let us find out some identity. Now you can prove also this one. You can prove sin square theta plus cos square theta equal to 1. This one you can prove also, because this sin square theta means sin theta whole square, right? Sin square theta means sin theta whole square, and we know that sin theta is p upon h. So sin square theta will be p upon h whole square equal to 2 bits. The left hand side is equal to left hand side sin theta is b upon h and cos theta is b upon h. Cos theta is b upon h. So you can write this is b upon h whole square equal to, now you can simplify easily. H is in the denominator, so h square p square plus b square. Now in a right angle triangle, what is p square plus b square? It's known to you, all of you, by using Pythagoras theorem. Okay, p square plus b square, which is in the numerator, it can be p, suppose this is theta, this is p, this is b, this is h. So according to Pythagoras theorem, your p square plus b square equal to h square. So in the numerator, that is p square plus b square, right? I can replace this one as h square. Denominator h square cancel out 1, which is equal to right hand side. Right. So sin square theta plus cos square theta equal to 1. You can prove it by from the okay. Now similarly, one more identity you can prove is 1 plus we will not do now. Okay. Let's solve some question. Now let us solve questions from previous year, some sample paper, previous year board questions. Okay, so let us solve few questions. So try these questions. If 10a equal to 4 by 3, find sin a plus cos a. So the question and try to solve it. If question is, if 10a equal to 4 by 3, find the value of sin a plus cos a. So to find the value of sin a plus cos a, so how will you do that? So tan A is given 4 upon 3. That means indirectly the side length of the sides are given. So how you will solve this type of question? Now 10a is 4 by 3. That means in a right angle triangle, let's say ABC, this is your A angle, means theta angle 10a. Okay. Now if this is theta, then this will be P, this will be your B, and this is your H. So 10a, we know that by B, which equal to 4 by 3 here. That means your P is 4x and B is 3x. You can take like this. And if it is B is 3x, E is 4x, what will be the H? Using Pythagoras theorem, you can calculate 3x whole square plus 4x whole square under root, that is 9, 16, 25x square, which equal to 5x. So 5x is your hypotenuse. Right. Now you have to calculate sin a plus cos a. So sin A equal to P by H and cos A equal to D upon H. What is P? P here 4x and H is 5x plus, that's why I told, if we consider only 3 and 4 also, you can solve it without considering x also. B by H, B is 3x, H is 5x. So you have to basically add 4 upon 5 plus 3 upon 5, LCM 5, and this is 4 plus 3, 7 upon 5. So this way you can solve the question. Now let us solve one more problem. If this question came in 2012 board exam, so let us solve this question. If tan theta plus cot theta equal to 5, the question is if tan theta plus cot theta equal to 5, find the value of tan to 2 theta plus cot theta. Find the value of tan 2 theta plus cot theta. So you have to find out this one. So how will we start? Let us start from here. So given that tan theta plus cot theta equal to 5. Now we'll square both sides. So squaring both sides, what will get? A plus b whole square you can put here. Tan plus cot theta, right? So tan plus cot theta, tan square theta plus cot square theta. A plus b whole square is a square plus 2ab plus b square, or a square plus b square plus 2ab. So 2 tan theta cot theta equal to 25. 5 square is 25. Now tan theta into cot theta, this is also a, means you can multiply, and one relationship is there between tan theta and cot theta. Can you say what is the relationship between tan theta and cot theta? I have already told that tan theta is inverse of cot theta. They are just inverse of each other. So tan theta multiplied by cot theta is 1, because 1 upon tan theta is cot theta. Okay. So this is one relationship between tan theta and cot theta. So here tan theta and cot theta will become 1, and you can write tan square theta plus cot square theta. This is 1, so 2 equal to 25. Right. We have to find out tan 2 theta plus cot theta. We have to find out tan 2 theta not we have to find out tan square theta plus cot square theta. We have to find out tan square theta plus cot square theta. So easily we can do tan square theta cot square theta is here. This number take to the right side. Then you can easily find out tan square theta plus cot square theta equal to 25 minus 2, so 23. Okay. So now let us solve one more question. Before that, let me explain that what will be the angles, means what will be the value of this sin theta, tan theta for different angles. So now we will solve or we will find out the values of trigonometric ratios for different angles. We will find out that. So for that, let us make one table. Let us make one table. So the table you can make like this. Okay. And for your to remember this table easily, first is ratios, then 0 degree, 30, 45, 60 and 90. Right. So what we are doing, we are finding out so what we'll do, we will find out the ratio of different trigonometric ratios for different angles. Okay. Suppose your triangle is, this theta is 30 degree. Then what will be the value of sin 30? Sin 30, this is your P, this is your H. So it will be P upon H. Now this sin 30 will be a constant. You make the triangle in any way. Okay. Suppose you are increasing P and B, a smaller triangle of 30 degree or a larger triangle of 30 degree, theta 30 degree, the ratio will be same. P by H for sin 30, it will be always a constant, and this will be half. So you can remember this one, that for 0 by 4, then root over, then hence the trick. This is 0 by 4 root over, this is 1 by 4 root over, this is 2 by 4 root over, this is 3 by 4 root over, this is 4 by 4 root over for sine theta. You should remember this one. Then other value you can write down from sine only, because all are interrelated with each other. All are interrelated. So you can find out this value, or you can fill up the table. So sine 0 is 0, 0 by 4 root over also 0. So this is for sine, and this table I am making, I will write sine, this is cos, this is tan, this is cot, and sec, cosec. Okay. So all the 6 ratios are written. Now sine 0 is 0, sine 30 is half, 1 upon 4 root over is half, 3, this is 3 by 4, so this will be root 3 upon 2, sine 45 degree, sine so this is 0, 1, this is 2, so this is 2, 2 by 4 is half, this is 1 upon root 2, sine 45 degree is 1 upon root 2, and sine 60 is, this is root 3 upon 2, 4 root over is 2, root 3. Now 4 by 4, this is 1, 1 root over is 1, right? Now you can write or fill the box for cos. Now cos is easy, right? Cos is easy. You will start cos 0 is 1. Just with reverse sign you will get cos. Okay. Cos 0 you will get 1. Cos 30 you will get root 3 by 2, cos 45 is same, 1 upon root 2, sin 45 and cos 45 same. Sometimes in the exam the question asked that for what angle of a right angle triangle both sine and cosine are equal. So for 45 degree, sin 45 is 1 upon root 2 and cos 45 is also 1 upon root 2. Now what will be cos 60? Cos 60 and sin 30 are same. It is half. And cos 90 is 0. Now tan theta you can write. Tan theta is the ratio of sin by cos. Sin theta and cos theta is tan theta, right? So you can fill the box like that. But if you know that tan theta is sin theta by cos theta, so basically if you remember the sine part, then other one you can easily do. Okay. So tan theta is sine by cos. So that means tan theta is 0 by 1, tan 0 is 0, 1 by 2 root 3 by 2, this is 1 upon root 3, 1 upon root 2, 1 upon root 2, This is 1. So tan 45 is 1. Root 3 upon 2 half. Root 2 cancel. Root 3. And 60 is root 3. 1 upon 0. This is not defined or 1 upon 0. So infinity or not defined is the better one. Okay. Okay. So now cot. The cot you can do both way. Like cos theta. What is cot theta? Just reverse of side. This is cos theta upon sin theta is cot. Cos theta upon sin theta is cot theta. So you can write cos theta by sin theta is cot theta. You can write here, or you can write 1 upon tan theta is also cot theta. Cot theta is also equal to 1 upon tan theta. That's the reverse of tan theta is also cot theta. So you can fill the table that is for cot 0 degree. We'll start to reverse it. Okay, 1 upon 0. This is not defined. Then what will be cos cot 30? Cot 30 will be just reverse, that will be root 3. And cot 45 will be 1. Cot 60 will be 1 upon root 3. And this is 1 upon infinite is 0. Right. Then how you fill up the table for sec theta? How will you fill up the table for sec theta? Now we know that sec theta is the inverse of cos theta. We know that sec theta is inverse of cos theta. Sec theta is inverse of cos theta. So you can write sec theta is equal to 1 upon cos theta. Sec theta is equal to 1 upon cos theta. So here cos table you can see cos 0 degree is 1, cos 30 degree is root 3 upon 2, cos 45 is 1 upon root 2, cos 60 is 1 upon 2, and cos 90 is 0. Now remember one thing, that these are some standard value we have taken. It's cos 0, 30, 45, 60 and 90 we have taken. These are the standard means it will be used for different calculation. But it does not mean that only these values are there. You can make a right angle triangle of 35 degree. Right. Now once you make a right angle triangle of 35 degree, so you can also find out the value of sin 35. How will you find out? Because you know it's P by H, measure with your scale, and P, the value of P, measure value of H, you will get something, because these are nothing, just the ratios. These are nothing, just the ratios. So sin 35 also you can calculate, that is P upon H you can calculate, and you will get some ratio, and that ratio will be in between half to 1 upon root 2, that means 0.5, it will be slightly greater than 0.5. Okay, so sin 35 also the value exists, but we have taken only this 5 angles for our convenience and to solve different problems. Okay, we can also find out the ratios for other angles also. So now, and also the angles beyond 90 also exist, like in class 11 you will learned about sine 120 degree, sine 135 degree, sine 150 degree. Okay, so greater than 90 also you will learn in your class 11. The value of sine, cos, all these trigonometric functions, therefore different angles beyond 90 degree also. But for now in your class 10, we'll restrict ourselves our discussion to only up to class up to 90, 0 to 90 degree. So sine 35 also exists, or sine other angles also exist. So that is not the point. So now, how you will write sec? How you will fill up these blanks for the sec theta? So as the relationship between sec and cos is just inverse with each other, so sec I can write just as inverse. So sec theta, sec 0 will be 1 by 1. This is 1, and 1 by root 3 upon this is 2 upon root 3. Sec 30 and sec 45 will be 1 upon root 2, 1 by 1 upon 1 upon root 2, that is root 2, and this will be 2. This is 1 upon 0, this will be not defined. Similarly, you can write for cosec also, but when you write cosec, you will check that if you just reverse the sec, then you will get cosec, or you can write 1 upon sin theta is also cosec theta. Cosec theta is also 1 upon sin theta, right? Cosec theta is also 1 upon sin theta. So sine values, these are the sine values. So cosec theta, if you calculate, then it will be 1 upon 0, that is, you start from modifying. Then cosec 30 degree will be, sin 30 is half, cosec 30 is 1 upon half, that is 2, and 45 will be root 2, this will be 2 by root 3, and this will be 1. Now you try to remember this table. Many times it will be used in solving different problems. So you have to remember this table, or you have to remember these values in a logical way, so that suppose you know the value of sine 45 degree, you know that cos 45 degree is same. So you means with a with a comparison or a logical way, you can remember these values. Okay. So now the table is in front of you. Now let us solve few questions. So let us solve one problem. The problem is, if 10 of time for alpha plus beta. Now there is a